So radical equations, our questions will be coming from sheet 4. Those will be our examples under radical equations. So we'll start with A. Question 1A. So we are solving for x. X minus 1 is equal to the root of 3x plus 1. What do? We square on both sides. Square on both sides. So we're going to have x minus 1 squared equal to the square root of 3x plus 1 squared. So that we'll have x squared minus 2x plus 1 when we expand the left-hand side. And on the right, we'll remain with 3x plus 1. Because that square there is going to take away the square root. So now we push everything to the left. So we're going to have x squared minus 2x minus 3x plus 1 minus 1 equal to 0. So we are sure that 1 minus 1 is 0. So we'll have x squared minus 5x equal to 0. So we factor out x, then we remain with that, giving us x0 or x minus 5 equal to 0. So that this x becomes 5. Now, under radical equations, whenever I find the values of x, I must go back to the original radical and test if these values are satisfying that equation. So I will substitute that value of x both on the right and on the left and see what I get. Is the inequality making sense, is the equality making sense or not? So we take 0. Okay, so testing x is equal to 0. We substitute, we have 0 minus 1 equal to the root of 0 plus 1, because 3 times 0 is 0. This will give us minus 1 equal to root 1, meaning minus 1 equal to 1, which is not true. Okay, what do? We discard this value. We discard x equal to 0. So we go to x equal to 5. Substitute, so we have 5 minus 1. Is it equal to 3 by 5 plus 1? Root, let's see. 5 minus 1 is 4. And this is 15 plus 1, root 16. Root 16 is 4 for sure. So then, the only solution we have is x equal to 5. Is that fine? Okay, good. So then we can do another one. So do the one which has 2. So do part F, which is 2 plus the root of x minus 2 equal to the root of 2x plus 3. So whenever I have 2 roots, I will make sure that one of those roots is on its own one side. Like in this case, it's fine. So here we'll go straight to squaring. So square this side and also square this side. So we're going to have 4, okay, it's 2 plus this multiplied by 2 plus this equal to 2x plus 3. Then now we expand. 2 times 2, 4, plus 2 times root x minus 2 plus root x minus 2 times 2, it's 2 root x minus 2. Then the root times root, we remain with the inside, equal to 2x plus 3. So then we can add these because they are alike. So 2 plus 2, that will be 4, the root of x minus 2, equal to, we take everything else the other side. So we have 2x minus x plus 3 minus 4 plus 2. So I've taken these, and that the other side. So that I can write as 4 root of x minus 2 equal to 2x minus x, that's x. 3 minus 4, that's minus 1, plus 2, that's positive 1. So we square again. We square this side, we also square this side. Okay, the square of 4, because this will be like 4 squared, and then this squared, equal to x plus 1. Squared means x plus 1 multiplied by x plus 1. Like that. So we have 16 x minus 2 equal to x squared plus x plus x plus 1. Meaning 16x minus 32 equal to x squared plus 2x plus 1. So now we want the x to be positive, so we'll take these the other side, minus 16x plus 1 plus 32 equal to 0. So I've taken these the other side, and because of the equal sign, we can write in either way. So this is x squared minus 14x plus 33 equal to 0. Okay, so can we find two numbers when we add, we get negative 14. When we multiply, we get 33. I'm thinking of negative 11 and negative 3. If we add them, that would be negative 14. If we multiply, that's positive 33. So write this as x squared minus 3x minus 11x plus 33 equal to 0. So we have x minus 3 minus 11, x minus 3. So that x minus 3 multiplied by x minus 11 is 0. So x is 3 or x is 11. So we get these numbers and substitute back. Remember, testing is always very important. So we pick x equal to 3 and substitute there. So we have 2 plus the root of 3 minus 2. Is it equal to 2 multiplied by 3 plus 3? So this is 2 plus 1, and that is root 9. Okay, so 3 is equal to 3, yes. What about x equal to 11? That will be 2 plus, that will be 2 plus 11 minus 2 equal to 2, 11 plus 3. So we have 2 plus root 9, that is 3, equal to 22 plus 3, that's 25. So again here, 5 equal to 5. We tick. So x is equal to 3 or x is equal to 11. Both values are solutions. So you see, in the previous one value was not a solution. So we had to throw it away. We said we discard that value. In this one, after testing, all the values have satisfied the equation. So we pick all of them as our solutions. So that's what we do in all the cases there. Okay, so we should be fine with that. The case of C, you square, again you square to get rid of the square, of the square root. So that one, or let me demonstrate 2 steps and then I'll leave it for you to finish. C, the root of the root x minus 5 plus x equal to 5. So the first thing you do is you square this side and square here so that it becomes root x minus 5 plus x is equal to 25. Then now you move. So you have this equal to 25 minus x. And then now you can square this side and square this side. And then you can finish from here. Testing, you test in the original when we are done. Like that. Remember that whenever you are testing, if you substitute a value and gives you a negative in the root, it must also do the same on the other side. Whenever you get different values on different sides, then that's not a solution. So we put to rest the case of question 1 and move to question 2. Unless there are questions there. Feel free to ask questions, guys, so that you don't waste a lot of time when you're studying on your own. Okay, so
it's always necessary that we have to prove, well, we have to test.
yeah, you always have to test for radicals, for as long as they are radicals.
Okay.
Yeah. So next, we look at graphs of radicals. We are now on question 2. A. F of x is 2 plus the root of x minus 1. So these are the very easy questions that you should never miss in any test, in any quiz or any assessment, because they're not complicated. The first step, so I'll do these in steps. Step 1, equate whatever is in the root to 0. Okay? So we're equating here x minus 1 to 0. And then solve for x. We get 1. You see that? After I get 1, step 2, substitute the value of x obtained in step 1 in f of x. So we substitute this, we'll find 2 plus 1 minus 1, giving us 2 plus root 0, which is equal to 2. You see that? Then now we have obtained the starting point. The value of x that we got, 1, comma, the f of 1, which is 2. This is the starting point. This is the starting point of this graph. So now I'm going to put my graph. Starting from where? 1, 2. There. It will start from there. I need to check whether it's going to the right or to the left. So I go and get my domain. Whatever is in the root should be what? Remember domain of radical functions? The x minus 1 that is in the root should be greater or equal to 0. Whatever is in the root must always be greater or equal to 0. We don't care about that 2 that is outside. Our interest is in the root. Okay? Meaning that x should be greater or equal to 1. So we know x goes to the right of 1. So it means that our graph is going to be this one. Because our domain is 1 to infinity. The question says, also find the range. So what's the range? Look at our function, it's going up. Starting from 2, going up. So our range is from 2 to infinity. Because the range, we look at the y values. So from y, it's going up. The domain x is going to the right. That's why we've said, you see? So because the values of y are going up, so the range is 2 to infinity. The values of x are going to the right, so the domain is 1 to infinity. The question could be, going to the right, yes. It could have also gone to the right, but down. Why up? Up because of the positive. This positive has taken it up. If it was minus, it would have gone down. So we'll do another one. So let's go to B. F of x is equal to 3 plus the root of 1 minus 3x. As usual, 1 minus 3x equal to 0, meaning x equal to 1 over 3. So you take your time when solving there, it will be -1, then you divide by -3, so the negatives will cancel. Then what is f of 1 over 3? Automatically, it will be 3 because this will be 0. So my starting point is 1 over 3, 3. So what's the domain? Remember we said 1 minus 3x should be greater or equal to 0, meaning minus 3x should be greater or equal to -1. When I divide by -3, divide by -3, the inequality will change. So now the domain is minus infinity, 1/3. So when I put my sketch, it's going to the left. Starting point, 1/3, 3. There. Let me put it a bit down. Here. Then I check outside. I know it's going up. I know it's going to the left. Is it up or down? I come and check this side. It's positive, so it's going up. So left up, meaning that it cuts the y-axis. I know how to find the y-intercept. How do I do that? I take 0 where there's x. I will have 3 plus root 1, which is equal to 4. So that's 4. What's the range? It has gone up. So the range is from 3 to infinity. Not so complicated. Another one. C. C, f of x equal to -4 minus the root of x plus 3. First step, we get x plus 3 equal to 0. So x is equal to -3. Substitute this guy, we'll get -4. So starting point, -3, -4. Domain, we get x plus 3 greater or equal to 0, meaning x greater or equal to -3. So domain, -3 to infinity. Greater to infinity. If it's less, negative infinity to that number. And then we check, it's minus. So it's going where? Going down. So this one to the right. So to the right and down. So see, because it's down, I can write the range in advance. Okay, the range is from negative infinity to -4. So on the starting point, the first number is for the domain. The second number is for the range. See, -3 in the domain, -4 in the range. Starting from where? -3, -4. Here, going where? Going down to the right. So it will be like that. So it's crossing the x, the y-axis. Where? At f of 0. -4 minus root 3. -4 minus root 3. Full stop.
Yeah. Just repeat out when you know it's going to right or left.
How do you know it's going right or left?
Yes.
You look at your domain. If it's going to infinity, then it's right. If it's coming from negative infinity, then it's left.
Okay.
Yes. So if you check the previous question that we did, it was going to the left. Why? Because it came from negative infinity to 1/3. So when doing the inequality, if your inequality changes, then you know that it won't go to the right, it will go to the left. Okay. So I leave you with the remaining questions for your exercise. We go to question 3. Question 3, these are modulus equations or absolute equations. Three A, solve each of the following. 2x minus 1 equal to x plus 1. Every time I'm dealing with absolute equations, you only do two things. You equate 2x minus 1 equal to x plus 1. Or 2x minus 1 equal to negative x plus 1. Then you solve. That's how you get rid of the absolute values. So you have 2x minus x equal to 1 plus 1. This will be x equal to 2. The other side, you have 2x minus 1 equal to minus x minus 1. That is 2x plus x equal to minus 1 plus 1. So you get 3x equal to 0. So x equal to 0. These ones, there's no testing. Once you underline them, those are solutions.
So what if you could change it to 2x minus 1, then x plus 1?
Huh?
What if you get negative to enter to 2x minus 1, then x plus 1? How is it?
How is it 2x? Okay, I can have to get you though. Okay, let's do another one and see if your question was to be there. Just do B. 4x plus 3 equal to 3 minus x. To remove the absolute, we'll have 4x plus 3 equal to 3 minus x as your first equation. Or your 4x plus 3 equal to minus 3 minus x as your second equation. This minus, if you want, you can put it this side. If you don't put the other side. Okay. So if I wanted here, I would have said minus 4x plus 3 equal to 3 minus x, because the same thing, like you can divide the negative. Okay. Then now we solve. So we have 4x, then this x crosses the equal sign, it will be plus x. And then we'll have 3 minus 3. When it crosses the equal sign, it becomes minus. So we have 5x is equal to 0. So x is 0. The other side, 4x plus 3 equal to minus 3 plus x. So we have 4x minus x equal to minus 3 minus 3, meaning 3x equal to minus 6. Divide by 3, divide by 3. So you get x equal to negative 2. So these are the solutions. No testing. Okay, do we get worried if we have two of them? Look at D. D, we have 4x plus 9 equal to 2x minus 1. Are we worried? We do the same. 4x plus 9 equal to 2x minus 1, or 4x plus 9 equal to minus 2x minus 1. The same thing as if we didn't have absolute on both sides. We take plus or minus on one side. So this one will have 4x minus 2x is equal to minus 1 minus 9, giving us 2x equal to minus 10, and so x equal to minus 5. The other side, we have 4x plus 2x equal to 1 minus 9. So we get 6x equal to minus 8. And so x equal to minus 8 over 6. We can divide 2, so it's minus 4 over 3. Okay? What about E and F? Let's start with E. E has x squared minus 4x equal to...
Can you send the
Hello? Hello? You were saying something.
Can you kindly read the
What's happening with D? So D, after we separated the two, okay. So D, we said that we are doing D as if it's A or B. There's no difference. So we'll have 4x plus 9 equal to 2x minus 1, or 4x plus 9 equal to negative 2x minus 1. And then we solve normally. Okay, so we take 2x the other side. We'll have 4x minus 2x equal to minus 1 minus 9, which is 2x equal to minus 10, and so x equal to minus 5. We go again on the other side. This will be 4x plus 9 equal to negative 2x plus 1, meaning it will be 4x plus 2x equal to 1 minus 9. So we'll have 6x equal to minus 8. So when you divide, you get this, which is minus 4 over 3. Okay. So we can log out and log back. So we can carry on because we have 2 minutes. So maybe we can finish E and F in those minutes. So let's log out and then we log back quickly.